Intros are going to be 10 minutes, so this is going to be really quite brief. So apologies if I kind of gloss over the Deep Space Network and how we do all the data collection, but I'm going to go fast. Okay, so this is me. If you want to contact me, I'm at Cloud Sasha everywhere. So I work at a NASA center. It's called Jet Propulsion Laboratory. You might know it if you're from the area. If you don't know it, it looks like this, and it's very close to ArtCenter. NASA JPL actually predates the agency. So we started in 1936, and NASA became an agency in 1958. So we were pretty cool and kind of forward-thinking before NASA was even around. And the things that we did were first ballistic missile testing, but that's not very cool. What is cool is making Explorer 1. So Explorer 1 is the first satellite launched for the USA. It is the answer to Sputnik. I'm originally from Russia, so this is difficult for me to say. I don't pick a side, but Explorer 1 is cool because it actually did science. Sputnik did not do science, but it got up there first. I don't know, choose your own adventure on that one. So it also was the first spacecraft to detect the Van Allen radiation belts, and I could do a whole lecture about that, but I'm going to spare you. But if you want to talk about that, let's meet up after this. We are the center of the universe at JPL. What does that mean? It means we have mission control. So this is a little GIF showing mission control in 1964 versus present day. It's gone through a lot of different iterations. One of my favorite is the late 80s, early 90s version that does look exactly like the next generation. So what is mission control? Mission control is how we talk to all of the spacecraft flying in space right now. And I'm not talking just US spacecraft, I'm talking about every single one. So anything that's robotic and up in space, we talk to them through mission control. And the way we do that is through a set of antennae called the Deep Space Network that are in 3 different parts of the world. There are a set of them in Goldstone, just north of here, and if you haven't visited, you can get tours there, in Australia and also in Spain. So they're approximately 120 degrees apart in longitude. So as the Earth rotates, they're able to talk to us and beam back signals both to and from Earth, specifically from JPL. So it's a really wonderful place. Also, JPL does public tours, and if you haven't done them, you should come. Tell them you know me, and I'll run down and give you a hug. Also, they book 6 months in advance, so make sure and mark your calendars. So my first love of coming to JPL was through Mars Curiosity, which is a rover that's been on Mars for about 6 years now. It was a 90-day mission that has lasted this long, so you can say we're pretty good at robotics. If I didn't mention it, we focus on robotic missions to space, not really human space flight. But I will show you a little bit of how we do that in just a second. So Curiosity takes pictures on Mars, and they look like this. And as was mentioned in my intro, I was able to take this image and create this, which was the first 360-degree video that was released publicly for NASA, and that came out of NASA JPL. And so instead of seeing something that's called an equirectangular image like this, that we would release these kind of things to the public, and if you didn't know kind of immersive media, you'd be like, wow, that rover looks like it's melting. But then when you put it in context and show how big the dune was in front of the rover and really be able to stand in the wheels of the rover, it really changed the way the public started kind of engaging with our material. And it also changed the way that I thought about media in general, because this was a really successful public media campaign, and I became obsessed with 360 video, made a bunch of them. I'll have a link at the end where you can download and make your own 360 videos out of our content, because all of our content is for public to use. But that brings me to where I work now, which is called the Ops Lab. The Ops Lab is short for Operations Laboratory. We got one person here that also works in the Ops Lab. Who else? It was just Alana. That's Alana. She's awesome. The Ops Lab is kind of a place that takes and transforms the way that we think about mission operations. So we're using new technology and innovation to change the way that scientists and engineers view and use their data. And one way that we really broke through in this category was through augmented reality and mixed reality, specifically with the Microsoft HoloLens. So we actually created the first application for the HoloLens device alongside Microsoft before this was a publicly available device. And that is called OnSite. Alana actually works on that project and the next iteration of that project. And what that project does is take data from Curiosity, pull it automatically down, and be able to create a 3D mesh. So what our scientists do is they virtually walk on Mars and look at different outcrops and geological features. So our geologists are able to study the surface of Mars the same exact way that they could study our own Earth. And this is done either wearing this device or on the web, and they can do it collaboratively. One scientist can be in Pasadena, one scientist can be in France, and they can be looking at the same exact outcrop on Mars. And I'll have a visual for that in a second. We do another project that looks at AutoCAD or CAD visualization and makes it turn to full scale. So basically the same concept of using a HoloLens device or the web to look at your spacecraft and basically build it before it's actually machined at all. So you're really solving a lot of problems in the engineering process before they happen. And really what you're doing is solving this question that engineers have a lot at NASA. Does this thing fit into this thing? Sounds really simple, and we've done a very complex kind of piece of software to solve that problem, but it's really useful, and we focus on that. We also have 2 HoloLenses up in the International Space Station. As promised, we have some human spaceflight in here. Here we have Scott Kelly, who spent a year in space, wearing one of the HoloLenses and doing a very simple procedure execution, meaning he's getting some instructions virtually instead of doing it on paper. And we're doing a lot of research in this world right now about heads-up display training versus training on paper. And as promised, this is the on-site application that I talked about before, where you can virtually walk on Mars. That yellow guy is an avatar. I shouldn't say guy. They're supposed to be not men or women, but I feel like Microsoft did a very strange job designing them. I can talk about avatars all day. Don't tell Microsoft I said that. But this is an example of someone working on a computer and also being able to see a Mars terrain in front of them and work virtually with John, who can be anywhere. Let's say he's in Arkansas. I don't know. So as was also mentioned in my intro, I have a passion about turning these projects into something publicly available. So we created accessmars.com in collaboration with Google Creative Labs, which is basically the same terrain that we use for on-site and other applications. And you can explore Mars on your own from your desktop. So if you go to accessmars.com, you can be on Mars. It's really fun to show people at parties. I think that it's like a #1 hit. We also have Spacecraft Ar, which is an application for your phone, which is kind of the CAD visualization publicly available project. So in this, you can look at a spacecraft or a rover in full scale. You can also, which is huge, like Juno in the middle there is like 3 basketball courts, I believe. So it's kind of like, where am I? So you can scale things down. You can also start a collaborative session with someone else. So you can pretend to be a mechanical engineer. And if you love it, come and apply for a job at JPL. So as promised, if you go to the bit.ly that I have there, you can download all of the 360s that are created from every NASA center and kind of glitch them out and make your own art out of them. And if you'd like to reach me or see more of about these projects, you can go to my website or follow me on social media. And that's that. Was that 10 minutes?